There are two examples you need to know. First one is a plain old sine x equals 0.8. This is not on the unit circle, so we are going to sine inverse. On my calculator, when I sine inverse both sides, I get an answer of 0.927, and I just rounded to the third decimal place. But you have to think about this on the unit circle still, because there are two answers for sine. One is the sine going to be about 0.8, and the angle here that we found is 0.927 radians. Now, there's another place where sine is that high, reflected over the y-axis. And so what my strategy here is, I'm going to find the distance or the angle between these 2 points and add it to pi over 2 to get over to that point right there. And pi over 2, if you take 3.14159 divided by 2, you get about 1.57. So the difference between 1.57 and 0.927-ish, that's going to be about 0.67. So the spot here, right here, is 0.67. That's the extra radians it takes to get from our point here to pi over 2. And so we're going to add that to pi over 2 again. We're going to take 1.57, we're going to add 0.67 to go that extra distance. Now that comes out to be 2.24. So we have two different answers here. We have 0.927. We also have 2.24. But remember also that we could add 2 pi and we could return to where we were. So I'm going to add plus or minus 2 pi k plus or minus 2 pi k. So I have two base answers and then all the associated answers if you were to go around the circle more. Alright. Now we're going to slide on to another example here that you need to know. You're going to encounter a lot of problems that involve cosine of 2x. This right here is a double angle. And based on our formulas, we have three different ways to write cosine of 2x. We could write it cosine squared minus sine squared. We could write it 1 minus 2 sine squared theta, and we could do 2 cosine squared theta minus 1. Now, if I'm looking at this problem, I probably want to choose the one that matches with what trig function we already have. So I'm going to plug that in. Sine of x plus, and then this would be 1 minus 2 sine squared x equals 0. Now this is already equal to 0, so we're going to factor this now, but let me write it in standard form first. Okay, and then I'm going to think of this as negative 2x squared plus plain old x plus 1, and I'm going to factor. Now I'm going to use the trick method, so I'm going to multiply a times c, and I'm going to factor first this, which comes out to be a positive 2 and a negative 1, but then we divide that negative 2 back out. So my answer will be x minus 1, and this does not come out, so I could write this negative 2x minus 1. Alright, so let me bring this over here. That would be really sine of x minus 1, and then negative 2 sine of x minus 1. Now we have two problems that we're going to answer here. We have, when is sine of x minus 1 going to be 0, which is the same as when is sine going to be 1. We know that is true when x is going to be pi over 2. Now we could add or subtract as many 2 pi's as we want, and we would have the same position on our unit circle. So I will add that. That is one part of the answer. On the other side, we have to ask the question, negative 2 sine x minus 1 equals 0. So I'm going to add 1 over, then divide by negative 2. So that'd be a positive 1 over a negative 2, which is negative 1/2. And there are actually two places where this can be. When x is, this would be the position 30 degrees past 180 here. So that would be pi over 6 plus pi. That would be 7 pi over 6. And then plus or minus 2 pi k. The other place, and I realize this might be too low down there, so I'm going to take this drawing and scoot it up a little bit. The other place where we have this height is back this way at basically negative pi over 6, which is 11 pi over 6. And then we plus or minus 2 pi k. Okay, those should all work in sine of cosine, so if I plug it back in, there's no erroneous answers. And we have base answers of pi over 2, 7 pi over 6, 11 pi over 6, and then we just plus or minus 2 pi k.